Next piece of line is the cross rail casting. This is what the cross rail casting looks like. Now, I had been asked in the past about order of operations and my philosophy for that. And on this particular part, I'm going to do the back first because it's big, it's square, it's reliable. It should be relatively easy to cut. And then I can flip over, hold on that, and do all the work on this side and the sides, etc. But in order to cut this surface, I need to cut these surfaces right here, the elevated parts, first. I want to clean those up first so I can hold on that, so that I can cut this, so that I can turn this over, go back and finish that. So it's a 1, 2, 3 or 1, 2, 1 kind of operation. Let's put this over in the mill. Actually, let's take it to the bench. I'm going to clean this back surface up with a file so that it's nice and clean. Take the burrs off the outside corners, take any casting imperfections, top and bottom, give it a little mechanical look-see, and we'll go from there. Here we go. In order to get a better grip on this part when I flip it over, I'm going to clean up the front and rear surfaces, just minimal, and I'll clean the top two surfaces as well. Once I know that I'm getting relatively close to the net shape that I'm looking for, I'll take an outside measurement on the part, and I'll also take a wall-to-wall measurement on the part to make sure that the cut is central to the casting. Make my adjustment on my digital readout so that I can bias one side over the other. You can see there's about a 0.003 difference, or a 1/10 of a millimeter difference in the two sides. And I'll take my final cuts to bring it into dimension. Quite often you'll see me set the height of my tool with a gauge pin or a block of a known size. Do not drop the tool down on top of the pin. Lower the tool and then roll the pin underneath to make sure that you don't chip your cutter. Then just drop the cutter or raise the table the diameter of the pin. And a quick look at the progress so far before we start moving this piece around. The perimeter is complete, and the depth of the side cut has got to blend with the original cast surface. That's why you can see a little bit of porosity in the front and a cut in the rear. That's got to be due to the draft. But that is what you're looking for here. That is your reference surface, and you work up from there and then down into the pocket. Now we're going to stand it up and do some work on the back side and the two sides. This should fit nicely on top, flush top and bottom, and slide freely, which it does. That's a good thing. All little scratches will go away before assembly, so not to worry there. All right, let's put it back in the machine, stand it up. We're going to cut a groove across the back side here for the back side of this guy right there. That's going to be a little J-channel lock right there, and it's going to lock onto a lead screw, which is going to go through the side, through that hole, And when you turn it, it's going to articulate the table. There you go. Let's make some chips. Next operation on this part is to cut a slot parallel to this front face here. Now, although you can say relatively confidently that this part is all parallel and you can hold it like this, dimensionally, it is always a good idea to clamp or register the part from the surface that the dimension is given from. So if this part were to vary, in thickness, this slot would be off if this face was registered on this side. So if the dimension is given from this face, hard bank it against the stop, against the vice jaw, whatever you need to do. That way the thickness of the part can vary considerably and your feature will always be right where it needs to be. And it is really tough to look in the camera and find the part at the same time. So if you see me fumble fingering around like that, that's why. Anyway, always bank the part against the surface from which the dimension is given. Okay, 1,000 pieces, you're going to find one piece that's not the same. When you trust it to be the same, scrap. Okay, let's do this for real. Put a slot in there. First step in this operation is to just gently bump both sides of this bottom casting. You'll see a little witness cut show up towards the front. It shows up towards the front because there's a draft surface here. You can see the little shiny part right on that edge. I'm going to do the exact same thing to the other side, and I will zero my digital for a central reading. Or at the very least, when I go to knock that web off on each end, I know where the ends are. Now right now I am coming up with the table ever so slowly, so if you see it just track on one side and not the other, that is not a tapered surface, that is the elevation of the table kicking in. That allows me to scratch that surface and come up with a very accurate depth for this cut. As you may recall from the earlier operation, there are no reliable surfaces currently exposed on this part. So I'm going to indicate the width of the jaws to come up with my y-axis. And now I'm indicating on the finished surfaces, although it looks like I'm indicating on a cast surface right there, I'm actually indicating on the far end of the part. So these are machine surfaces. I'll set my digital for a 0 x-axis center line and go from there. Initially, I will not trust this, so I'm going to take cleanup cuts and check it before I finish. The height of the back side of this part is given from a cast surface, so I'm going to use a 10,000 shim and come up with the table ever so slowly until the shim starts to feel resistance. I will not drop the cutter or raise the table with the shim in place. That is a great way to blow the edges off of a carbide cutter. Whatever size shim you use or method you use, don't forget to include that dimension in your calculation. Lower the table, start your cuts. Very rarely do I go to net size on one cut. I will always leave a little bit of material and walk back across it for the finish. This will now be my 0 surface and allow me to raise the table or drop the cutter to get all the other dimensions on all the other features. I did go back and forth a couple times to establish this dimension, but I edited out all of those redundant steps for time conservation. Now it's time to center drill and drill all the holes for the hold down clamps. I'm making a very mild dimple in the part right now, and I'll check it visually and make any adjustments I need to make before I go to full depth. By making a very superficial dimple, if you make an offset with the cutter or the table, the diameter of the final feature will consume that dimple and you won't see it. This is a 1.5 millimeter drill going about 6 millimeters deep, so it's an 0.59 diameter drill, and I'm not just punching them through. I did edit out all the pecks, so it took several strokes to get these holes to depth. This is a 172 tap. It's a size 1 72 TPI tap. It's not a .172 tap. If you haven't made one of these little knurled thumb wheels for your smaller diameter taps, you really should. It gives you great feedback and reduces the chance of cracking it. I will bottom tap these by hand outside the machine at a later date. This particular side hole was lined with a square to establish vertical, and then the edge finder was used to set the offset from the stationary jaw. Drilled and reamed to 125. This is the hole that will control the elevator mechanism for the table. The next two holes that I'm doing now will control the screw that moves the apron across the face of the machine. Now, the inside of this pocket is a cast surface, and you just can't trust the drill for length or location coming out the other side. So this will be one hole per side, but they should be in line when you're done. Next operation is to address the small pocket in the front. In order to do this, it's got to be positioned like this. Thought it was worth a look. The parallels are moved over because I have two parallels on the stationary jaw. I moved it over to the solid part of the solid area of the part so that as I tap it down, I won't influence the little tab. I won't bend it if that's even a possibility. So I just didn't even want to try that. Put myself there. Moved over. We're going to tap it down. Indicate it in. I'm going to sweep the pin And then I'm going to sweep in between the channels right here, and I'll have my zero location for the pocket. Let's do it. I'm about to indicate this part, and I'm going to attach my indicator to the chuck body. So I put a dummy plug in the chuck and lock it down so everything is nice and solid. This is a shop gem all day long. If you're going to put an indical holder or any type of indicator holder on your chuck, make sure that it's gripping something. And just so I don't cut myself and I have a lot of space underneath, it is usually just a 3/8 dowel pin. It's the same pin that I use to roll across the surface of the part to set the height of a cutter. All right, I got to say that I'm very pleased with that. We've got a little bit of witness casting right there, which is probably a good sign. The driving boss on the side was the alignment feature for pretty much everything else. So I'm very pleased with the way that just came out. It is time to stand it up and put a through hole in here and a counter bore, and that is where the bevel gears will come together for the elevation of the table. Final feature is a through hole and a counter bore, this location right here. I'm going to pick it up by sweeping the pin since it's critical and sweeping the gap. That'll give me my XY center. Down I go. And for all you detail-oriented guys that are going to say, hey, there's no pin in the chuck, you'll also notice that the indicator holder is now connected to the spindle of the machine and not the chuck body. To complete this feature, I'll put the counter bore in, and yes, there is a cup shape on the bottom of the end mill. But if you make your cut when it cleans up, there may be a high spot in the bottom of the pocket, but that will be the maximum depth of anything that can go in that pocket. I know what this is going to be used for, and a 1,000th or so taper on the bottom of this pocket, no big deal. All right, guys, after minimal deburring, this is what you can expect. There are a lot of features on here that are relative to other features, so if you do this, be careful of your sequence. Don't get caught up in things. This through hole here was called for a drilled hole, but I reamed it because, you know, when you drill something and it's a half a hole, it gets that scallop look to it. I thought a reamer would give me a better finish, and I was right. See if I can get a good look at how those holes line up. Yeah, huh? You saw me do one from each side. It's because I just couldn't trust the drill to stay on target, especially since it's a cast surface on the other side. If it would have hit it, it would have walked. And I'm talking about that area down inside the pocket in the back. That's why you saw me stand this up and do it, one from each side. Anyway, I suppose that's all we got for today. Thank you very much for tuning in. I hope you're enjoying this series as much as I am enjoying doing it for you. Stay well wherever you are in the world. Joe Pye here at Advanced Innovations in Austin, Texas. I'm out.